Assalamualaikum and hi. So today we'll enter a new chapter, chapter 2, Kinematics of Linear Motion. So the first subtopic here is a linear motion. And our learning objective for this subtopic is to define instantaneous velocity, average velocity and uniform velocity. Also to define instantaneous acceleration, average acceleration, uniform acceleration. And lastly, the third learning objective here is to discuss the physical meaning of displacement versus time graph, velocity versus time graph, and acceleration versus time graph. We'll be looking at all these three learning objectives today. But before that, we'll do some recap on our prior knowledge here. Okay, the first thing that we're going to look at is the distance. So as you can see, distance is the actual path between 2 points. So this is actually the definition of your distance. Let's say you have point A, point B, and point C. So what you did was you started your journey from point A, you went to point B, and then from point B you went to point C. So the journey from point A to point B is 5 meter. And the journey from point B to point C is, let's say, 4 meter here. So, the distance here is defined as the actual path between 2 points. So, your point here, your 2 point here is your starting point and your end point. So, you started your journey at point A and you end your journey at point B. So, the total distance that you have covered here is 5 meter plus 4 meter. So, this is what we call as the actual path. Okay, distance is a scalar quantity and has a unit of meter here. Whereas a displacement is the shortest distance from initial position to final position. So it is basically the shortest distance from 2 points. So referring to the example given above here, what you did was your journey started from point A, you went to point B, and then you went to point C. So your starting point, your initial point here is A, and your final position here is your point C here. So displacement here is referred as the shortest distance from initial position to final position. Maksudnya, it is the shortest distance that you could take to reach a point from a point. So you started your journey from point A to reach point C. It is not necessary you must go through 5 meter plus 4 meter. You can straight away use this path here. So we can simply use, let's say I'm going to use a different color here. You can simply use from point A to point C, and you can also reach a point C. And as you can see, the distance, your distance initially was 5 plus 4 meter, whereas your displacement now will be 6.4 meter. This only take up 6.4 meter. So the displacement is a shortest distance between two positions. Okay, displacement is a vector quantity, and we know by now vector quantity is a quantity that must have magnitude and also a direction. And it also has the same unit as your distance. Okay, so distance and displacement, they basically are the same thing. They want to measure the distance. It's just that they want to measure the length. Okay, they want to measure the length. Okay. However, distance, they measure the actual path. Apa saja perjalanan yang kamu lalui, dia akan kira. Displacement adalah the shortest one to reach a point from a particular point. Okay, next thing that we're going to look at is the average speed and also average velocity. Okay, average speed is defined as, or in equation, it is distance traveled divided by the elapsed time. Or the total time taken here. So to find speed, what you do is you take distance, you divide by the time. Okay, so since your distance is a scalar quantity and you divide by time, time is also a scalar quantity, you end up with your speed as a scalar quantity as well. Okay, so jarak, the total journey yang kamu lalui bahagi dengan masa yang kamu ada, kamu akan dapat average speed dekat sini. Okay, it is a scalar quantity, it does not have direction, and the unit here is meter per second. Next is the average velocity. Average velocity is the displacement travel divided by the elapsed time. So apa kita buat adalah, you take the displacement yang tadi kamu kira which was the shortest distance, you divide by the time taken, to reach that particular point, you get your velocity. Since your displacement is a vector quantity divided by time is a scalar quantity, you end up with your velocity as a vector quantity. Maksudnya ada magnitude dan juga ada direction. The unit here for velocity is the same as your speed, iaitu ms negatif 1. Apa yang membezakan mereka adalah satu adalah scalar quantity, hanya mempunyai magnitude. Another one is a vector quantity, mempunyai magnitude dan juga direction. Okay, so now we'll look at the first learning objective and the second learning objective, which is to define instantaneous velocity, average velocity, and uniform velocity. Also, the second one is to define instantaneous acceleration, average acceleration, and also uniform acceleration. So the first thing here is the average velocity. Okay, average velocity is actually the displacement travel divided by the elapsed time, which is basically, in short, a rate change of the displacement. Okay, average velocity is the one that we have actually looked, which is our prior knowledge in actually. The displacement travel divided by the elapsed time, or also in short known as the rate change of the displacement. It is basically how fast and in which a direction an object is moving during the elapsed time. Okay, maksudnya betapa lajunya sesuatu objek itu akan bergerak in a certain direction, dalam sesuatu arah dalam masa yang diberi. That is what we call as average velocity, which is change in displacement over elapsed time, ataupun by equation kita boleh tulis here delta S over delta T. Okay, next adalah instantaneous velocity. Okay, next is the instantaneous velocity, which is the average velocity over an infinitesimally short time interval. Average velocity over an infinitesimally short time interval. Basically, apa kita nak cakap adalah it is how fast the object moves and in the direction of the motion at each instant of time. Okay, basically kita nak tekankan pada sesuatu saat itu, at a particular instant, how fast your object is moving in a specific direction itu. Okay, so the V instantaneous is actually equals to limit delta T approaching 0, delta S over delta T, which is actually ds over dt. Maksudnya pada saat tertentu, at a specific instant. Okay, next adalah the uniform velocity. Uniform velocity, moving with the same velocity at each instant of time. Maksud uniform velocity adalah nilai velocity kamu tidak akan berubah. Magnitude of the velocity is constant and the direction remain unchanged. Maksudnya dua-dua tak berubah. Nilai dan juga arah sesuatu objek itu tengah bergerak tidak akan berubah. Okay, so dia akan ada nilai velocity yang sama, itu kita panggil uniform velocity. Ataupun dalam kata lain, kita juga akan panggil dia constant velocity. Uniform velocity is also known as constant velocity. Maksudnya magnitude dan juga direction velocity itu tidak berubah over that period of time. So V uniform dia adalah ds over dt, which is equals to constant, satu nilai yang sama. Contohnya, at the beginning of the journey, you started with speed of 2 meter per second. At the end of the journey dan juga throughout sepanjang perjalanan kamu bergerak dengan 2 meter per second. Tiada perubahan dalam nilai kelajuan kamu dan juga arah kamu bergerak itu. Okay, so that's all about velocities here. So next kita dah tengok pada acceleration pula. Untuk acceleration, the first thing that we are going to cover is to define the average acceleration. So average acceleration dekat sini, okay, average acceleration dekat sini adalah the change in the velocity travel divided by the elapsed time. Okay, average acceleration adalah change in the velocity. Perubahan dalam velocity dibahagi dengan masa yang kita ambil, kita akan dapat kita punya average acceleration itu. Ataupun dalam kata lain, it is the rate change of the velocity. Okay, so change in the velocity, which is basically kamu ambil perubahan dalam velocity kamu. Contohnya V final minus V initial divided by the T final minus T initial, kamu akan dapat delta V over delta T. So this is your average acceleration. Okay, next adalah instantaneous acceleration. It is the average acceleration over an infinitesimally short time interval. Okay, sama juga macam instantaneous velocity. Instantaneous acceleration adalah acceleration yang kita nak tahu at a specific position or a particular time along the path of the motion. Maksudnya pada saat tertentu tu kita nak tahu apa acceleration objek tersebut ataupun pada kedudukan tertentu, exactly at a particular position itu. Okay, you want to know that instantaneous acceleration. So dia adalah basically sama juga limit delta T approaching 0, delta V over delta T is equals to dV over dt, which is actually also equals to you differentiate your displacement twice. Okay, to get your acceleration, you differentiate your displacement twice. Okay, sama juga dia kita nak tahu at a specific instant, pada saat tertentu, at literally particular saat dia akan bagi tahu. Contoh dia nak tahu find the average acceleration at the at 2 second. So kita dah tahulah kita nak cari T kita adalah pada saat kedua itu. Next adalah uniform acceleration. Uniform acceleration is moving with the same acceleration at each instant of time. Maksudnya dia akan bergerak pada had laju yang sama. You're going to have the same acceleration throughout your journey. The magnitude of the acceleration is constant and the direction remain unchanged. Magnitude tak berubah, direction pun tidak berubah. Maksudnya kita panggil dia uniform, constant. So A dekat sini sama dengan dV over dt, which is also means you have to differentiate your displacement 2 kali, is equals to constant. Right? Okay, before I proceed, saya nak recall sikit balik. I hope you still remember displacement kita guna simbol S dekat sini, velocity simbol V, acceleration kita guna simbol A dekat sini. Okay, displacement adalah shortest distance, betul tak? Velocity pula adalah shortest distance itu divided by the time. So V kita adalah ds over dt ataupun change in the displacement over change in the time, iaitu S final minus S initial divided by T final minus T initial, itulah kan. Alright, and then at the same time if you can see, kalau nak cari acceleration kita pula adalah dV over dt. Awak akan differentiate velocity pula. Okay, you want to differentiate your velocity. Velocity ni kita dapat macam mana? Sebab kita differentiate displacement. So basically you're going to differentiate the displacement twice in order to get the acceleration. So ini adalah relationship antara mereka. This is actually your prior knowledge. Saya nak recall sikit lah. Takut kan ada yang tak ingat pula, tu bahaya. Okay, next adalah there are few things kita nak emphasize on the relationship between the velocity dan juga acceleration dekat situ, iaitu if the velocity of an object decreases from the initial velocity. Okay, initial velocity kita guna simbol initial velocity, kita guna simbol U untuk membezakan antara dua velocity yang berbeza, iaitu initial dengan final. Okay, dia kata, saya ulang soalan, situasi kita. If the velocity of an object decreases from the initial velocity U to a lower final velocity V. So kita ada final velocity dekat sini pula, kita guna simbol V dekat sini. Dan dia kata apa jadi adalah velocity kamu ini berkurang. Sebab apa? Dia kata initial velocity kamu lebih tinggi daripada final velocity kamu. Dia kata decreases to a lower final velocity. So kalau kita nak bagi dari segi number, contoh initial velocity kamu tu saya cakap 10 meter per second. Okay, lepas tu kita cakap final velocity pula V dekat sini adalah 5 meter per second. So maksudnya pada asalnya you're going to travel with kelajuan yang lebih tinggi, and then after some time your velocity decreases, berkurang. Okay. Okay, at this particular point apa yang akan jadi adalah basically this process kita panggil your acceleration is a negative acceleration atau kita panggil dia deceleration. Acceleration kita adalah negatif dekat sini. Acceleration negatif ataupun kita panggil dia deceleration. Okey, apa yang Miss maksudkan dekat sini adalah kalau kamu tengok equation untuk acceleration adalah, tadi saya cakap acceleration adalah delta V divided by delta T tadi. Okay, delta V adalah change in the velocity, iaitu velocity akhir tolak dengan velocity initial. Velocity akhir kita adalah 5 meter per second, tolak dengan velocity asal kita 10 meter per second. Bahagi dengan katakan saya bagi masa dekat sini adalah sebanyak 5 saat. So what is going to happen here is you're going to get 5 minus 10, kita dapat negatif 5. Negatif 5 bahagi dengan 5 kita dapat berapa? Negatif 1. So ini adalah acceleration kamu, negatif 1 ms negatif 2 ni, iaitu negatif 1 meter per second square. Okey, negatif dekat sini, apa yang dia cuba indicate adalah, negatif daripada jawapan yang kita dapat ni, dia tengah cakap adalah kamu punya objek tengah mengalami negative acceleration, iaitu dia tengah decelerate. Okey, dia tengah decelerate. Okey, maksudnya your object is slowing down. Objek kamu tengah mengurangkan kelajuan dia, macam seolah-olah dia nak slowly berhenti lah kan. Okay, so during this time object is slowing down, ataupun kita cakap direction of the acceleration is opposite to the direction of motion or velocity. Boleh jadi juga you were to have negative acceleration, boleh jadi because your object is moving in the your acceleration is in the opposite direction to the direction of your velocity itu. Alright. Okay, jom sekarang kita sama-sama tengok example 3 dalam nota kamu. Your example 3 from your notes is basically about average velocity. Okay, dia nak cakap pasal average velocity dekat sini. Okay, what we have in the question adalah a bus travels along a straight road for 600 meter. Maksudnya kita ada bus. Bus ini tengah bergerak along a straight road for 600 meter. So, ini jarak yang kita nak cover lah kan. It travels at a constant velocity. So dia cakap constant velocity for the whole journey. So sepanjang 600 meter ini kita bergerak dengan velocity yang constant. Remember tadi apa maksud constant velocity adalah velocity yang kita panggil uniform velocity. Berbalik ke table dekat atas, kita ada 3 jenis velocity: average velocity, instantaneous velocity dan juga uniform velocity. Uniform velocity, moving with the same velocity at each instant of time. Maksudnya magnitude of the velocity constant, direction remain unchanged. Nilai dan juga direction dia tidak berubah, kita panggil dia constant velocity, which is actually your uniform velocity. Okay, coming back to the question. So dia kata the bus is travelling at a constant velocity for the whole journey, which takes 90 seconds. Okay, what was the velocity of the bus? So sekarang kita tahu kita ada bus tengah bergerak. This is your bus. Okay, so bus ini ada perjalanan yang dia nak cover, iaitu perjalanan sebanyak 600 meter. So 600 meter ini sebenarnya adalah displacement kamu, jarak yang kamu nak lalui dekat sini. So you have 600 meter to cover. And this whole journey takes, masa yang dia ambil adalah 90 saat. Kenapa dia ambil 90 saat adalah sebab kita telah menggunakan sesuatu kelajuan, iaitu velocity yang uniform sepanjang 600 meter ini. So dia tanya apa nilai V itu. So kalau kamu tengok kamu ada displacement dan kamu ada masa dekat sini, kamu nak cari V. So kita akan guna paling basic, equation yang paling basic dekat sini adalah V is equals to S over T. Sebab dia adalah uniform dekat sini, delta S over delta T. Okay, kalau kita nak tulis secara detail boleh juga, iaitu delta S over delta T. Delta S adalah final displacement minus initial, iaitu awal-awal dekat sini awak belum start, tak ada perjalanan lagi, kosong. Bila awak sampai sini 600 meter, so 600 tolak dengan kosong divided by time taken. At the initial point sini T kita adalah kosong. Bila awak sampai sini, the whole journey take 90 seconds. So 90 tolak dengan kosong. This is why, so kita boleh abaikan untuk tidak tulis lah, sebab kita dah tahu tak, initial dia adalah 0 here. Okay, so 600 awak tekanlah calculator, bahagi dengan 90, awak akan dapat velocity yang uniform tadi itu adalah sebanyak 6.67 ms negatif 1. So sepanjang 600 meter ini awak telah bergerak dengan kelajuan 6.67 meter per second. Okay, very good. Okay, next kita nak tengok example 5 from the notes as well. Okay, example 5 dalam nota ini adalah regarding instantaneous velocity dan juga acceleration dekat sini. Okay, what we have in the question is a particle moves along horizontal line according to the equation given that S is equal to 3t cubed minus 4t square plus 2t. Okay, so kita ada particle moving along a horizontal line according to this equation, where S is the displacement in meter and T is the time in second. So S dalam equation ini adalah displacement, whereas T dalam equation ini adalah masa. At time T is equals to 2 second, determine the displacement of the particle. So maksudnya kita nak tahu pada saat kedua T sama dengan 2 second. Okay, apa adalah nilai displacement kita? Maksudnya kita berada pada jarak, what you have displaced how much in that particular 2 second. Sebab asalnya awak tengah bergerak with this particular equation. You're moving with respect to this equation where you have displacement in terms of time. Okay, kita ada equation displacement with respect to time. Okay, so dia kata at 2 second determine the displacement of the particle. So kalau kamu tengok, kamu dah ada equation displacement sama dengan 3t cube tolak dengan 4t square campur dengan 2t. Okay, so sekarang bila dia cakap at t is equals to 2 second, apa jadi kepada S? So ini basic. Okay, this is like your simple maths. Dia bagi equation S with respect to t. Dia dah bagi nilai T, sekarang dia suruh cari nilai S. Apa yang awak patut buat? Masukkan je lah nilai T itu, sebab bila dia bagi dari segi equation dekat sini, apa yang dia nak sampaikan adalah kamu punya S, nilai S ini akan berubah setiap kali nilai T yang kamu masukkan dalam equation ini berubah. Okay, pada T 1 saat, S kamu lain. Pada T 2 saat, S kamu lain. Pada T 3 saat, S kamu lain. Okay, as your time changes, your displacement is going to change. So sekarang dia dah bagi tahu secara jelas T adalah 2 saat. Maksudnya kita tengah cakap pada instant, at a particular instant, at 2 second. Okay, so S akan sama dengan 3. Substitute 2 dekat tempat T. Setiap kali kamu jumpa T, kamu masukkan 2 campur dengan 4. 2 square campur dengan 2 darab 2. So sekarang tinggal nak tekan calculator. Cube salah, saya salah tulis equation. Ini adalah minus. This is minus. And then plus dengan, kita dapat 12. 12 apa? Ekor lembu. Jangan lupa tulis unit. We are talking about displacement. So 12 meter here. Okay, so pada saat kedua, kita dah display sebanyak 12 meter. So the next question here adalah B. Dia cakap masih bergantung kepada saat yang kedua ini. At T is equals to 2 second. At T is equals to 2 second, determine its velocity. Okay, so bila dia kata pada saat kedua, cari velocity pula, we are talking about instantaneous velocity. V instantaneous. Okay, at T is equals to 2 second. Sebab that particular instant. So kalau kita berbalik ke table kita dekat sini, kita ada instantaneous velocity here is ds over dt at a specific time, iaitu ds over dt. Apa maksud ds over dt dekat sini adalah to find velocity, you have to differentiate your displacement. Okay, so to differentiate your displacement, apa kita ada dekat sini? ds. Kita ada equation of S with respect to t, betul tak? Since kita memang ada in terms of equation, so kita differentiate dia teruslah. Kita guna kaedah ini. Okay, ini differentiation kamu dah belajar waktu SPM, if I'm not mistaken, you have studied this lah. Tapi tak apa, we'll go together. How do you differentiate? Ini adalah kita nak differentiate with respect to t dekat sini. Okay, setiap part of the equation ada t, so kamu kena differentiate. So kita tengok pada 3 t cube dulu. Apa yang akan jadi adalah power bring in front and then power minus 1. So 3t cube, power dia adalah 3, betul tak? So saya cakap power bring in front. So 3 tu jangan kacau, tulis. And then t cube, power kita adalah 3. So bawa power bring in front and then power minus 1. So tulis balik t, power minus 1, 3 tolak 1 dapat 2. And then minus with 4, jangan usik, kekalkan. T square, power bring in front, square bawa ke depan, and then power minus 1, 2 tolak 1 dapat 1. And then plus with 2, jangan tukar. T dekat sini, T punya kuasa berapa? 1. Power bring in front, and then power minus 1. 1 tolak 0 dapat 0, betul tak? So T to the power 0 dapat 1 dekat sini. So what you have here is 9t square minus 8t plus with 2. Okay, so ini adalah equation dia untuk velocity. Kita belum jawab soalan kita baru cari equation with respect to t sekarang sebab dalam soalan kita dia bagi dari segi equation. That is why kita guna differentiation dekat sini. Okay, so now what I'm going to do is I'm going to find my v at t is equals to 2 second. So saya akan substitute 2 square minus dengan 8, 2 campur dengan 2. So 9, tekan kalkulator awak akan dapat 22 ms negatif 1. Okay, be good. Alright, untuk acceleration sama juga. Next we are going to proceed with the acceleration. Dia kata at t is equals to 2 second, determine its acceleration. So pada saat kedua, so we are talking about instantaneous acceleration. Instantaneous acceleration sama juga, iaitu dia akan jadi differentiating your v dekat sini, dv over dt. Okay, dv over dt. So kalau kamu tengok, kamu dah ada equation untuk v. So apa kamu buatlah, kamu kena differentiate dia saja. So this time saya nak go quickly sikit, saya nak laju sikit. Saya takkan tunjuk satu-satu, saya nak terus masuk kepada jawapan dia lah selepas saya differentiate. So A saya akan dapat power bring in front power minus 1, saya akan dapat 18t tolak dengan 8 dekat sini. Okay, this is what I get. And then at t is equals to 2, saya akan tekan kalkulator, 18 darab 2 tolak dengan 8. 18 darab 2 tolak 8, you should get 28 meter per second square. So this is your acceleration at 2 second according to this equation given. Okay, cara untuk dapatkan acceleration, awak differentiate v with respect to t. Cara nak differentiate dia adalah sama ambil equation ini, jadikan ini how, power bring in front. So power ni bawa ke depan, and then power minus 1. Sama juga dekat sini, power 1 t. Kuasa dia adalah 1, power bring in front, power minus 1. Dekat sini tak ada t. Bila tak ada term t, apa dia jadi? Kosong. Okay, tak ada term t langsung, so kita akan jadikan dia kosong, kita abaikan dia dekat sini. Alright.